All right, guys, we are ready for lesson 3. All right, so we're taking a look then at right triangle trigonometry. Now, this should be a review from last year, but I kind of had a feeling maybe you might need to think about this again before you actually used it. Um, so anyway, we're going to talk about right triangle trig. And basically, trigonometry is just the study of triangles. So it makes sense that the right triangle is a special case for trigonometry. All right, so when I draw a triangle and I label it, I use capital letters for the angles and I use lowercase letter for the sides, and lowercase a is across from angle A, lowercase b is across from angle B, and lowercase c is across from angle C. Now, in a right triangle, we have a right angle, right? And generally, unless otherwise specified, C is going to be that right angle. All right, so we have a little reminder, right? And there's been a lot of different ways that people came up with for people to remember that. But talking about SOHCAHTOA, right? One of the things that I heard that kind of helped me is some old horse caught another horse taking oats away. All right. I just kind of remember SOHCAHTOA, and I don't worry too much about that, but make sure that fits. All right. And what that means is that sine of the angle is equal to the length of the opposite side divided by the length of the hypotenuse. All right, and we're just going to use O over, H. Let me get a piece of cardstock to put underneath that to stand for the length of the opposite divided by the length of the hypotenuse. All right, and cosine A, CAHTOA, right, or CA, so it's adjacent over hypotenuse. So that's the length of the adjacent divided by the length of the hypotenuse. All right, so A over H is what we use to signify cosine. Now that's cosine of the angle, not the angle itself, right? The angle is a capital letter, all right, and cosine of that angle is an entity, all right? I can't just separate them, all right? Well, I can separate them, but there's only one way to do that, and I'll show you here in a second. All right, so tangent A, all right, that's TOA, so length of the opposite divided by length of the adjacent. All right, so we use O over A for that. Okay, so I talked about solving for the angle. All right, so let's say that I have sine A equals 12 over 19. All right, is that possible? Sine is opposite over hypotenuse. The hypotenuse has to be the biggest angle, okay, or biggest side, I'm sorry, and 19 is larger than 12, okay? So that's possible. All right, so what I'm going to do, the only way to separate sine from A, from the angle, is to apply the inverse of sine. So the inverse of sine is called arcsine, and it's written sine to the negative 1, the inverse of sine. So I apply that to both sides. Right? And all it means is to write that in front of both sides. Now, it's really important, the order here. You can't put arc sine to the right of the 12 over 19 because it's become an entity when I apply that to both sides. Okay, so arc sine and sine are the opposite of each other. They cancel each other out. All right, so it's like squaring is to the square root as arc sine is to sine. All right, they're opposites of each other. This is called a bridge map. All right, so now I've got a by itself. So in our calculator, first thing we're going to do is we're going to go to the mode button and we're going to get in degree mode. All right, get out of there, and I'm going to do arc sine, second sine, 12 divided by 19. All right, so that angle is really blurry. Let me see if I zoom in a little bit. Yeah, it doesn't help much. And where's the focus? Right there. Yeah, it wasn't the best, but it's better than it was. All right, so rounding to 3 decimal places, it's going to be 39.167 degrees. All right, so that is solving for the angle only. That's the only time you use the inverse operation. Okay, so let's take a look then at some questions. All right, so the first question is in right triangle ABC, A is 8, B is 13, find the measure of side C. All right, so I want C to be the right angle. That's capital C. So that means to get a triangle, I've got to do in counterclockwise direction, ABC. All right, A is the side across from angle A. B is the side across from angle B. All right, and I want to find the measure of C. That's lowercase c. Now, in this case, this is not trig. Yeah, I know it says trigonometry right above it. Sorry, but I wanted to show you one that was different first. The problem here is that I'm not given an angle. All right, so if I have two sides of a right triangle and I need to find the third side, I use the Pythagorean theorem. All right, a squared plus b squared equals c squared. All right, so a was 8, b was 13. All right, and we're finding c squared. All right, then I'm going to take the square root of both sides to get c by itself. See, I kind of like to do all the algebra first. All right, so what I'm going to do here, I'm just going to put that last step in the calculator. All right, so the square root of 8 squared plus 13 squared. All right. Now, if we were going to finish this course, we would use this process a lot if I'm looking for that value. All right, so we're going to round to 3 decimal places and 15.264. All right, does that make sense? Hypotenuse has got to be the biggest side. 15 is bigger than 8 and 13, so yes. Okay. All right, number 2, right triangle ABC. All right, C is that right angle unless they say differently. A is 20. All right, that's the side across from angle A. Angle A is 42. All right, find side C. All right, so C is over here. Now, using SOHCAHTOA, I have to determine which function is going to work. Sines of functions, cosines of function, tangents of function. So that's what I mean by which function. All right, so I have the opposite, and I'm looking for the hypotenuse. So opposite and hypotenuse, that means I'm going to use sine. All right, so sine of the angle equals opposite over hypotenuse. All right, so now to get rid of a fraction, I multiply by the denominator. All right, I want to get c by itself. I've got multiplication, so I'm going to divide by sine of 42. All right, we're going to get an answer that's in decimal form, I'm sure. So 30 divided by sine of 42. 44.834. Okay, so we're rounding to 3 decimal places unless it tells us otherwise. Okay, makes sense? So hypotenuse, right? It's got to be bigger than 20. Okay, question number 3. In right triangle ABC, C is 18. C is the hypotenuse, right? Angle B is 61. Find A. A is the side across from angle A. All right, so now I've got the 61 degrees. X is adjacent. 18 is the hypotenuse. So adjacent and hypotenuse tells me I'm going to work with cosine. So cosine of the angle equals adjacent over hypotenuse. All right, so now we just solve for x. Now remember, guys, this variable can either be the angle, it can be the numerator or the denominator. So once you get it set up, solving that is not always going to be the same. You've got to deal with what's been given to you. All right, kind of like life. All right, so I multiply both sides by the 18. All right, so making sure you're in degree mode here. All right, I'm going to do 18 times cosine 61. All right, and 8.727 rounded to 3 decimal places. Okay, so just a reminder of that right triangle trig that you guys took a while back. I don't think it's in Algebra 1 anymore. I don't remember doing that the last couple of years. And I'm not even sure if you guys do it in 8th grade anymore, so you should have done it last year in geometry, though. Okay, number 4, in right triangle ABC. All right, now it really doesn't matter where you put the A and the B. The C is important as far as the angles are concerned. Just make sure that the side across is the lowercase value of where you put A and B. All right, A is 128. Ooh, our numbers are getting bigger. That's okay. The calculator will handle it. C, side C is 185. Find the measure of angle B. Okay, we're looking for an angle this time, so we're going to use the inverse. All right, so first of all, we got to determine which function to use. All right, 128 is next to angle B. It's not the hypotenuse, so it's adjacent. Next to, but not the hypotenuse, is adjacent. And then 185 is across from angle C, so that is the hypotenuse, right? So adjacent over hypotenuse. All right, we're going to use cosine. So cosine of the angle, this is angle B, is equal to adjacent over hypotenuse. Okay, so this time the variable is the angle. The only way to separate cosine from the angle is to use the inverse. All right, so I apply the inverse of cosine to both sides. All right, cosine and arc cosine cancel each other out. So in my calculator, I just put arc cosine, inverse of cosine. So second cosine 128 divided by 185. All right, and angle B is 46.220 degrees. Okay. Number 5. In triangle SAM, okay, did this on purpose because they like to mix this up a little bit. All right, M is the right angle. So if I'm going to do the counterclockwise thing, S goes up here and A, so SAM, all right, where M is the right angle. Okay, little a is 76, so that's across from angle A. Angle S is 48 degrees. Find S. Okay, so we're looking for the side across from angle S. All right, so now there's my angle I'm looking at. That determines what's adjacent, what's opposite, what's hypotenuse. Well, hypotenuse is across from the right angle. But X is across from 48, so that's the opposite, right? 76 is next to 48, but not the hypotenuse, so that's adjacent. All right, so adjacent and opposite. Adjacent and opposite means we're using tangent. So tangent of the angle equals opposite over adjacent. All right, we want to get the variable by itself. You get rid of a fraction by multiplying by the denominator. All right, so in the calculator is just 76 times tangent 48. 84.407 degrees. Nope, not degrees. It's not an angle. All right, number 6. In right triangle PQR, R is the right angle. All right, PQR. R is 15, right? So that's the hypotenuse. Angle Q is 25 degrees. Find P. Okay, so I have the 25 degrees. Never use the right angle, guys, when you're trying to find adjacent and opposite. It's always one of the other angles. All right, so 25 is adjacent to X and 15 is the hypotenuse. So adjacent and hypotenuse tells me we're working with cosine. So cosine of the angle equals adjacent over hypotenuse. All right, solve for X. Get rid of a fraction by multiplying by the denominator. What you do to one side, you have to do to the other. All right, so in the calculator, 15 times cosine 25 is 13.595. Okay. All right. So there we go. You have one more page to complete for your assignment and just get that back to me. Guys, in case you didn't figure it out, I'll let you figure it out. Okay. Have a good day. And hopefully this one went pretty well and pretty easy. And this is the end of week 1. We got another week to do. And I'll get you 3 more videos and assignments next week. All right. Have a good day and have a good weekend.